very much for coming today. This is the first AWS user group in Slovakia this year, and today we'll be doing the reInvent recap, which was in the topic of generative AI. So we have 4 guest speakers. First one will be Juraj Lišiak, who will cover the highlights and tech updates from the reInvent recap. Then we have our guest from Tatra Banka, who will talk about their experience and some tips and tricks how to get the most out of the event if you ever want to go or if you're thinking about it. And then Adam will tell us about AWS Graviton and what it does and how we use it in our day-to-day work. So I don't know if you've ever been to a AWS user group before. Yeah? So, perfect. So you know that this is a community event that is made so that we can enjoy or talk about cloud technologies, especially in AWS. And in Slovakia, it's been going on for several years, and it's been previously organized by the girls from StelERP, and we'd like to really thank them for building this community and putting it together. And now we're basically also starting to organize it, and we'll prepare some cool events in the upcoming months as well. And yeah, some organizational stuff. So we'll have like an hour and a half of presentations. There will be 3 presentations, and we can have some short breaks in between. And afterwards there will be pizza, snacks, and beers, and networking, and all the fun stuff. So I hope you enjoy it, and I will give my word to the first speaker.
So welcome. My name is Juraj Lišiak, and I'm the Senior Solution Architect, and my territory is Czech Republic and Slovakia. And what I'll be talking to you about today is, it's a kind of a recap, but it's going to be focused on Gen AI. So it's going to be very specific on our generative LLM platform. So the first slide here, it might be a little hard to see, but we have sort of 3 layers in our LLM platform. We have the foundational services at the bottom, and those are basically some of the things that if you've got your own models and your own things already built in, you've got your basically your model and your infrastructure built in, you can actually run it directly on some of our custom servers. For example, we have our Trainium processors. These Trainium processors are specifically designed for example, for training. And then we have the Inferentia processors, which are designed for inference. So you train the model on one type of processors, and then you actually do the inference on another type of processors. So we've got the hardware level if you actually want to build your own whole stack. If you look at the second layer, that's where we have this tool called Bedrock. So Bedrock is our platform for generative AI. And I'm going to talk about that a little bit more. But at the top level, we also have specific tools that are directly used for example, for translation, for transcribe, and for things like code creation. So we've got it covered in sort of 3 different ways. So builders can either bring their own models, use some of the foundational services, or go all the way at the front. So Amazon Bedrock, has anyone heard of this? Okay, we've got 2, 3 people. So this is our generative AI platform. It's our large language model. And what's actually a little bit unique about it, so you know, when we're talking about LLM, we're talking about Chat GPT and Vertex AR or Gemini, what it's called now. So this is our main LLM. What's different about it though, is it's actually using several different models, and you could choose which model you want. So most of these are open source. So if you look at, for example, the Llama 2, that's from Facebook and Meta. Then we have our own, which is called Titan, but we also have Stability AI and Cohere and Anthropic. And each of these models are slightly different, and they have very different use cases. Just recently we announced we're going to have Mistral. So Mistral will be available as a foundation model as well. And then if you don't want to use the foundation models, we have a partnership with Hugging Face, and Hugging Face has hundreds of different models that you can bring in, not at the bedrock level, but the level below, which is called SageMaker. So you can actually bring in the model, train it, and use it that way. So that's kind of the main difference and advantage that we have, is you get to decide which model to use. And as the models get more mature and become more sophisticated, you can implement them in the area. And the reason this is important, because if we look at text models, they're very different in terms of their training. So they're different in terms of the way they were trained, what the use case was, what the data was, and you want to be able to choose that model depending on your use case. Also the size. So some of the models are very different. For example, the Bloom model has 170 billion parameters, so it's the biggest model out there. And it doesn't necessarily mean it's better, but usually it provides a lot more results and context. So that's one thing that's also important. And finally, it's also the architecture. So how the embeddings are, how many back propagation layers they have, and as well as what type of transformers they use. So each of these models have a different aspect to them that you might want to choose and experiment with. When we're talking about user-facing components of this, you're going to look at the use case. Is it a conversational chat AI, or is it more summarizing data, or is it image generation or image augmentation? These are all different use cases that the different models perform differently on. Same thing with the languages. So some of the languages that are supported out of the box, again, differ between the models, and it's important to understand which ones are best for that. So for example, in the local market, like Czech Republic and Slovakia, some of those models actually are much better than the generic models, as well as the performance and context use. So, for example, if you're doing a lot of prompt engineering and you want to do sophisticated prompt engineering, you want to have a range of input models, or sorry, the input context size to be much higher. Otherwise, you won't be able to get those more complex fine-tuning scenarios. And then there's also customization options. So some of these allow for things like LoRa and fine-tuning, and some of the models don't. So they allow you to deal with the hallucinations in a different way that might be not available in other models. And finally, there's performance, and this is important for enterprises because training these and creating large models is very expensive. However, a lot of the times you can get very similar results with much smaller models, and these models are going to be a fraction of the cost. They're not going to cost you to implement them in that same level. So these are some of the things that have been announced at re:Invent, and as you can see there, we have Cohesive Stable Diffusion XL. This is for images. Claude 2.1, which is one of the top ranked models from Anthropic in terms of text generation. And of course, Llama 2, this is some of the open source components that have come from Meta and Facebook. So most of the models that are open source are going to be either available in Bedrock or in SageMaker. So it's very easy to start implementing those and using them. So, what is fine-tuning? Well, fine-tuning, as you can see, is just basically you're taking an existing large language model and you're fine-tuning it for your particular business case. And the way you do that is by providing it with labels. And labels are just basically data that is unique to your business case or to your company, and you're bringing it in. So let's go through, let's say, an example of that. So one of the things you can do with Bedrock is you're going to choose a model. So let's say in this case you choose Llama 2. And then you're going to find some labels from your environment. So if you're in the travel industry, you would provide data from the travel industry or whatever you're doing. You would add it into Bedrock, and then the model becomes fine-tuned for your particular use case. And from that, you can create generative content. So it's using the large language model with the customized use case and bringing these, bringing specific results based on your custom data. The other thing that's come up is RAGs. So these are basically retrieval augmented generation. This allows your model to go to third-party databases or systems or applications and retrieve data. So for example, you can ask the LLM to go into, let's say we're dealing with the air industry or flight industry, to look at your flight logs and retrieve data from your flight system, bring it back in, and then come up with the results. And again, this is built into Bedrock, and it's built also into SageMaker, the ability to have that RAG component where it's real time going into data that wasn't necessarily fine-tuned, right? It's kind of the next step. And again, this is where we have the agents for Bedrock. So basically allows you to directly connect your Bedrock fine-tuned model into the APIs, into your company's APIs, retrieve the data, and then have what's known as a chain of thought. So the whole thing is explained in terms of where did it start, what data did it get, how did it get that data, and how was it filtered. And this is another new announcement in reInvent. So let's go look over a quick use case. So this use case is question answering. So basically you have a customer and they have some questions they want to answer as an example. So what you would do is you would take your document archive, let's say your proprietary internal data, FAQs, things like that. You would ingest it into what's known as a knowledge base. And really, in this case, the knowledge base is really just the Amazon Titan encoding in a vector database. So that data now becomes parameterized. So you have all these parameters in your knowledge base. And then if a customer wanted to have a question about a flight, when is this flight supposed to arrive or come, or what's the best flight to get to San Francisco, it would go to that knowledge base using the Amazon Titan LLM along with the knowledge base and then get the data back. In most cases, we're not seeing that yet with customers because that's end data and there could be errors with that. I think there was an Air Canada chatbot that gave the wrong price and this caused some problems. So what we're seeing is more from the employee end. So employees are using it to look, instead of searching for data manually, they are using the LLM to basically query the data that's been trained on your knowledge base and then providing an answer and then creating and sending that over to, let's say, a database or a booking database. So it's something that's we're seeing from both the client side and the employee side in this particular case. And there are a bunch of other use cases. I have one here, but there's dozens of others. Okay. And again, the whole idea is that you're using the RAG, using the custom database, knowledge base, which is basically fine-tuning into that. The other thing that's important is the idea of responsible AI. There's different parts of responsible AI. Things like transparency, governance, and explainability. And traditionally, explainability has been something that's been done in linear or inferential AIs, like, for example, Shockley values. This is a little bit harder to do in Gen AI, but it's something that we're working on, and there's a bunch of frameworks we're putting in. So the first one that's important is the data residency and isolation. So when you are training the model with your data, that data stays in your AWS account. It doesn't actually leave anywhere else. And then you control the residency. So if you want it to only stay in the European Union, you have control over that. So it separates the large language model from your own proprietary data that's being used to fine-tune and do the RAG. So that's one important thing, and it's very important for most companies. There's also guardrails. So some of the guardrails we have for Amazon Bedrock are things like making sure that certain information doesn't get retrieved or communicated. So one example is PII. So this is personally identifiable data. So for example, if there's a query and something comes back with personal information about a customer, you don't want to have that information come out to you during that query. So some of the guardrails that actually we're working on is to remove any PII data. There's other more obvious things like things that are illegal and things of that nature. The way it actually works in terms of a high-level architecture is you have the user input, then before it does the inference, it actually goes through the guardrails. So it first looks at things like, okay, are there denied topics that the user is asking about? Are there particular content that we don't want to show or not show? The PII2 redaction would be another component, and then it could also be a word filter. So these are becoming more robust ways of filtering out and making sure that the final response doesn't violate your company's policies or other regulations as well. And then finally, we have model evaluations. So one of the things we want to be able to quickly do is as the model is being developed and being trained, you want to be able to look at different models, be able to evaluate them, and then put that feedback back into the environment. So that was Bedrock. The other main tool we have is called SageMaker. So SageMaker is our main machine learning platform. It's used for generative AI, but other machine learning as well. And it's really kind of a pre-built platform that allows you to use existing models, like I mentioned from Hugging Face, or build your own model and start using it and managing it on your own. So one of the things we've done now is especially for large models, you require a lot of data processing. So this thing called, this new feature called Hyperpod basically allows you to scale out and manage that whole SageMaker process. So if part of it fails or part of it needs more processing power, it will manage that for you instead of you having to deal with the exceptions and manage that part of the process. Another tool is, this is our no-code platform. It's called Amazon SageMaker Canvas. And as of reInvent, it now supports the foundation models. So basically, you can start creating a lot of these queries without doing formal coding. So it's kind of a low-code platform. And then there's finally Studio. So again, SageMaker Studio plugs into your favorite IDE, so support for Visual Studio Code was put in. And it basically just allows you to take your Jupyter notebooks that you've created, visualize them and connect them and compare them to other parts of that. And it's highly portable. So basically, if you've got that component, you could move it to another region, you could move it to another SageMaker platform out of production into environment. So it just makes this whole process very easy to use. Last but not least is Amazon Q. So Amazon Q is kind of the brand name for embedding large language models into all of our products. So the first one is Amazon Q Business Expert. So what this is, for lack of a better term, it's similar to something like Copilot, where it basically integrates with something like your Slack and Salesforce, and then is able to do natural language queries, like create an email for me or create an invitation, and it will generate some of these things. If you've noticed our website as well, there's a new Q feature. So if you go to the AWS console or something similar, Q pops up in the corner, and you can start asking it questions in natural language. So I just did this with one customer. They were using AWS config, and you have to create queries in sort of a SQL language. And you just ask it, you say, hey, how do I create a query to count how much RAM we have in all our servers in Frankfurt? And Amazon Q will basically come back, okay, this is the query, select blah, 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 and it will create it for you. So instead of having to manually go in and create a bunch of, or go through a bunch of manuals, understand the context and syntax, it's an assistant. It could also be used for just simple things like, explain to me, how do I shut down an EC2 instance, or why is this EC2 instance failing? So you'll see this more and more embedded in basically all the products. It's going to have this Q component, which is basically a large language model. One of the more interesting ones is QuickSight, which is our BI tool. So one of the toughest things to do is to visualize the data. because you need to understand the data, you need to understand the way it works, how to do pivot tables and VLOOKUP queries and all this stuff. So Q has been embedded into that. So you basically just ask it and say, hey, I want to match all the servers from table A to table B and then display them in a increasing manner with these exceptions, and it will create the query for you. So that's kind of where Q is going. It's going to be pretty much everywhere. For those of you who don't know, we also have end users. These are not end user services, but they're API calls that you make. So, for example, Amazon Lex now has Gen AI built into it. So Lex is basically our speech assistant, similar to what's in use in Alexa. And then we also have personalized. So this is a personalized engine that Amazon actually uses. So when you go to Amazon and you make product and you see product recommendations, we use that. So now it's actually using LLM models and some of the functioning that. So things like next best action are LLM based, and things like transcribes. So one of the big problems is transcribe and translate is we didn't have support for Czech or Slovak. With LLMs, this is actually now possible because it's using the LLM to do the translation instead of the old way, which was not using LLMs. And then we have a couple of other interesting announcements around Gen AI, and it basically everything is being sort of infused with Gen AI, and that's what you're going to see more and more of. It's going to be very, very transformational. So that's it for me. I probably can't see my email, but if you want to try out some of these features, just send me an email. I'll get you like a $25 code to try it out. So thank you.
The next presentation will be my guys from Tatra Banka. Mário is an enterprise architect, and Michal is a cloud architect, and they will tell us a little bit about their experience at reInvent 2023, about the entire atmosphere, some tips and tricks on how to get the most out of it, and
Okay, thank you. So maybe at the start a quick quiz question. Who has visited the reInvent before? Okay, so a couple guys. Nice. Okay, so maybe something that we will tell you will help you, those that haven't been there yet, to navigate a bit better, or maybe to have something to look for. Just to start, it is probably one of the biggest, if not the biggest, cloud conference in the world, and the best to describe it is massive. It lasts for 5 days. It takes places in 6 different hotels across the whole Las Vegas Strip. I will stop here a bit, just to understand what does it mean that that it took place in 6 hotels. Each hotel has its own kind of inhiba. The bigger one, we can say they have like 2 inhibas, and it's really big. So to go around it, it would take you maybe 20-30 minutes. Those hotels are like big, from 3,000 to 7,000 rooms. So just to get an idea how big one hotel together with its conference halls is, and that Michal will tell you a bit about the logistic that is really important here. And I think the last year, 2023, there were around 65,000 attendees. So yeah, it's big.
Okay, maybe I would tell you something about the AWS partners. So especially they can tell you about the real experience from the integrating of AWS services, and maybe some problems also beyond the official statements of AWS. So or how you can improve with this AWS solution with their solutions, and on top of this. So yeah, there's a place for it, and to talk with them, and to yeah, get their experience and avoid some mistakes with implementation. So, okay.
Okay, maybe just to mention, and we will talk about it a bit later, there were around 2,000 plus sessions, so it underpins all the how long it lasts and so on. Okay, so a couple of pictures. This was just a central meeting point in one of the conference halls where you could get some like hoodies where you can meet. It was the single point of contact for anything to do with the reInvent. So just to get an idea that it's a big one.
Yeah, maybe some surprising thing. When we walked all this environment, conference environment, moving within these corridors, so and I measured the number of steps by these smart gadgets, and I was surprised that I had peaks of 45,000 steps a day. So just to imagine how big distances are between these hotels and these session rooms, and so.
Yeah. Okay. Part of the reInvent are not just the sessions, but also the expo, where you have those partners that Michal said. It's divided into different sections. That there is section for developers, security, compute. I think there was, and even on the second or third date, it's quite easy to get lost there. So I was always looking for a VMware booth because that was one of the biggest. So.
Yeah, also other sections like architecture, effective operations, and maybe governance for the managers. So if you send the team to this conference, everybody can focus to other section and yeah, get the most of all these topics. And
also RBI had a small session in one of the theaters.
Yes.
Okay, couple of pictures. So this was just one aisle in the expo area. So you can see that.
yeah, there is possible to collect swag from all these partners. Yeah, so you can have a quite big collection.
If you're lucky, you can even win some Lego or.
Yeah, there are plenty games.
You can find different things like F1 simulator is not that easy as it looks. I think you saw some robots going around, so yeah, some gadgets can be found there. Okay, tips and tricks for those that haven't been at reInvent yet. So you can go and visit the keynotes, but you need to go there like at least 1 hour earlier to get into the queue, wait, and so on. Or some of the keynotes were started at I think 8 a.m. So you can instead of that you can watch it online because it's streamed live, and you can have a nice breakfast instead of that. Also, as mentioned, there is like 2,000 plus sessions, so everybody who is suffering from fear of missing out, this event will teach you how to deal with it. It's not possible to attend everything, not even what you will plan. Probably you will miss some of those things anyway. And one more thing from my side, there are multiple events happening each evening. So the partners are doing some events where you can go, visit, have some networking, maybe some food and so on. There are events that are organized by AWS directly. So we learned it in the middle of our trip. So, but if we would knew that before, we could have a nice evening plan for each of the evenings.
One good point is to choose the one conference hotel and avoid moving between these hotels and conference centers, as it can take approximately maybe 1 hour and 30 minutes just to switch the hotel. So if you plan the day, it's good to pick up all the session from one hotel and avoid moving within the day. And what would be fine for the best session, it's fine to reserve the seats and to have reserved place session, because otherwise there's like 50% of capacity reserved for these who reserve these seats, and others needs to wait in line. So you don't have a guarantee that you can fit the room, and then you have to somehow replan your daily schedule. So for the best, it's fine to have reserved.
Yeah. Also, they have something like silent disco rooms. It was a big room, and if you didn't manage to get into the session directly, there was a high chance that in such places those sessions were streamed. So you could watch it, but not directly in the specific room. You just went here. There was an agenda, and you could. There were also streamed sessions that were happening in other hotels. So you could make a plan without moving to the hotel, to another hotel. But yeah. I was mentioning some parties. This was organized by AWS for EMEA region. It was nice, with a nice view, and I think that was a Bellagio fountain. Food, drinks, nice evening. And this one was also organized by AWS. It's called Replay, and that's kind of they organize basically a Pohoda music festival for one evening. A couple of like Pohoda.
Yeah, but I think it's bigger than Pohoda.
Oh, probably, yeah. As there was like 65,000 attendees. Pohoda is like what, 25, 30. So yeah, so they organized Pohoda for one evening.
Finally, this year was, or 23 was even some rock stages. Before it was mostly electronic music. Finally, it was even music for us only.
Okay. So also something about a bit technical stuff. There were different types of sessions. So from announcements of new features through keynote, you could go and do some hands-on labs, trainings and certifications, or breakout workshops, or there were sessions where the presenters were doing the presentation and doing directly on a board, like Chalk Talk. So it was a nice one. And the main themes, I had the feeling that every second session was something, one of these, whether it was Gen AI or resilience with observability, FinOps and governance.
Okay. Not all the sessions are appearing on YouTube, so sometime when I checked my my schedule, what I attended, and less than half of my session in my calendar are not on YouTube. So just don't expect everything will be online after that. So our primary focus was on resilient architecture, how we can improve our design, how we can enhance our solution, maybe to cross-region, how we can have under control the operation costs, and maybe improve efficiency in governance and observability, how to, yeah. And this is the example of the session, probably. And we didn't want to just deep dive into the technical details. So for those who are interested, you can find some materials from it. But yeah.
And here are some directly with some links. The first one was really nice. Like it was demo that they did how they came together with the Gen AI, build things, upgrade things from older libraries, and so this was really nice. It shows you how the future can look actually. So that was nice. Okay, we don't need to go through all of those.
Maybe I would highlight some of
Yeah.
it. Yeah, as we tried to get into one session and didn't fit to the room, so sometimes life leads you somewhere else, and so we accidentally found at this serverless streaming session, and I was kind of positively surprised. This demonstration of how can things go wrong when you just leave the configuration in default settings, and you don't realize all the consequences and limit of these services. So, and it can really lead to the loss of the data in streaming, and yeah. So okay. Some of the sessions are like design online, so it's like brainstorming session. Not all are prepared, well-prepared presentations. So yeah, diagrams are just designed online, and that's impressed me. Okay. Also, if you want to improve your skills, there's Skill Builder platform for self-paced labs, but there are some sessions that are not published just to the Skill Builder, and they just the most innovative ways were like in the preview session where they tested these labs. So, and if you have a free time, no interesting session, you can still spend time with these self-paced lab rooms and just take a lab, fill the gap. Yeah, that was fine. How AWS demonstrated how we can support the sustainability just to taking this circle with the full tanks of the water, and AWS committed that will pay $5 for every circle with full tanks, and yeah, just to delivering water pipes to the community around the world, and yeah, so we helped a little bit this way.
Okay. As mentioned before, there were interesting sessions. This was one of it. We were allowed to take just one photo at the beginning. they showed, and one of the presenters were actually a former mechanic from one of the F1 teams, and they showed the telemetry and a little bit of data behind the curtain directly from the Abu Dhabi. It happened like 2 weeks ago or something like this. So it was pretty up to date, and so at least one photo. Otherwise, they were pretty strict if someone tried to take another one. So also sessions that you would not expect are there. So this is just one of it, but there might be like different success stories from different partners. So you can find something always there. And the last one, we mentioned that those hotels are big ones. You always need to go through casino. There is not possible that you can get to the conference without at least once going through the casino. So, well, eventually it will suck you in, and yeah, someone will win, someone will lose. So, so at the end, the balance is always there, and yeah, the casino didn't lost anyway. So, yeah, that's pretty much it.
Okay.
Oh, no, I was the lucky one, so that's.
There must be balance in the universe, so I was the one who lost this time. Yeah. So.
Okay, and that's probably everything from us. So if there are any questions, feel free to.
Thank you for attention. So I hope we just encourage you to visit this conference and maybe to find new source of inspiration for your projects. And thank you.
Thank you.
So welcome again. My presentation is going to be about AWS Graviton. It's going to be much more nerdy than the presentations before, so feel free to either enjoy it or hate it. So my name is Adam Hamšík, as it was already said. I'm a CEO and co-founder, and also I'm a fan of different CPU architectures. So let's get started. So I have a warm-up quiz for you. So do you know what RISC or CISC means? And do you know if there is anything else missing in that sentence? Like, no. Yeah, it used to be a question, but I changed it. Those are different like CPU instruction sets, and the third one is a very long instruction word, or EPIC. It was Itanium CPU made by Intel quite a while ago. And the other question, maybe, do you know any other like RISC-based CPU designs? Like ARM obviously is one of them. Do you know anything else?
Power.
Yeah, Power. Yeah, that's good. Also, there used to be quite a lot of back in the Unix wars days, like AJ RISC or Spark. Yeah. So I had a question. I'm not sure, like, how many CPU architectures or CPU computers or computers with different CPU architectures do you own? Like, is there any other nerd here? I was counting them. I have 5. So it's MIPS, ARM, Spark, Power, and Intel. But whatever. Yeah, let's go. So generally, I co-founded Labyrinth Labs with two other guys, and both we all 3 of us are developers. So I used to be a DevOps engineer by craft, but now I'm doing a CEO job. And yeah, I did some kernel hacking and really enjoyed developing in NetBSD for a while. And for family hiking lacrosse, I play quite a lot of lacrosse as a sport. And yeah, that's probably it. Something about us, we at Labyrinth Labs, we are a one-stop shop for DevOps, cloud, and Kubernetes. For if you need anything else, we also can help you there. But this is our bread and butter, and we definitely can help you if you have any issues. Let us know. So I always try to put it too long, don't read section in front, because if you fall asleep right now, like you at least can take something from this presentation, and you're gonna be happy. We did some evaluation and migrations to ARM with different customers, and like 3 major points are that it takes quite a lot of time. Like it's quite unexpected, to be honest, but like we found a different misbehaviors, even with high-level languages like PHP or Python. Like we find out that it's not really that you take the application running on Intel and you can deploy it to ARM and you can expect same performance, same behavior. It's not like that. So make sure you know your application and you have good test suite, you have ability to run load tests to make sure that you can validate that your application is working very well. And also, like more deep you go, you find that there is quite a lot of highly optimized libraries around, like for compression, for crypto, for JSON parsing, and so on. And these are not necessarily always ported to ARM yet. Like the process is very often ongoing and it takes quite a lot of time because very often it's about optimization, porting it to like assembler level stuff, and sometimes it's not there yet. So make sure you know that and you can validate it. Generally, the main reason why we look at ARM as an option for our Kubernetes clusters were that like we already have to support that in some way. Like very often developers with our customers, they use ARMs in their like MacBooks. That's like very common these days. So if you have application, if they want to develop on their own computer, you already have to support ARM in some way. So you have to build your images for your application with ARM somehow. You have to be able to deploy there. And if we have to do that anyway, then we more or less can try to run it in production too. And the third one is that all major public clouds are looking at ARM as a CPU architecture and trying to build their own CPUs there. So AWS has Graviton, GCP and Azure, they use Ampere Ultra CPUs. Yeah, and what I'm really happy about is that the risk is finally back, and we finally have some other than Intel CPU instruction set somewhere. So we can actually come back to days where there were quite a lot of CPUs around and you could like go there and play with different architectures and computers. Like after that, there was quite a long period of time where only Intel was around. And now we have finally getting some diversification again. And that's NetBSD. So what's the difference? Like I think Intel or AMD 64 architecture is quite common. Like we very often have very large servers and experience with that. Also, what's quite important is that AMD or Intel as CPUs, they tend to use quite a lot of power. So they tend to generate quite a lot of heat. They tend to consume quite a lot of electricity. On the other side, ARM is a CPU which is powering your cell phone, and you can more or less scale it to server level stuff. And it will consume more power than the cell phone CPU, but it's still way less than what you can find in server level stuff from AMD or Intel. And that's really important for cloud vendors because they tend to run quite a lot of CPUs and quite a lot of servers. And even like 10%, 20% less consumption on electricity is really, really a game changer for them. So That's the main reason why big cloud vendors are looking for ARM as an alternative and a CPU utilization. And yeah, so generally ARM and Intel have different like models of operation. For Intel, there is a company, Intel and AMD, as everyone knows, and they develop their CPUs and they create their CPUs. You can buy them in a shop and whatever. That doesn't really work for ARM. It doesn't really work that way. There are ARM as company, it's only developing design. So they're like creating architecture design for these CPUs, and you as a company can go buy them or license them and then build your own CPUs on top of that. This has, like, you obviously have to have some engineering power and understanding for that, but also it brings quite a lot of value for you. You can build the different blocks, and we will talk about it later, how AWS is actually utilizing that to build different CPUs coming from very same original design, helping them with very special and different cases. Yeah. So yeah, ARM is licensing those CPUs to different companies like Apple, Qualcomm, Ampere, AWS, and they all like develop their own custom architecture designs. So generally, like where you can find a very good CPU where you can really run your workload is like a Mac like there, and if you use the first one, there was a CPU M1, and they're based on different ARM architectures, or ARM architecture instruction sets. There are different like versions. Very often they use big little architecture, so you have different cores for performance and for like smaller and not that performant tasks. And they are very often based on CPUs you run on your cell phone. So what is really interesting about Apple itself is that they can actually run Intel code like natively on your on ARM CPU. They build a system which will translate the Intel instructions into ARM and can actually execute it natively with very good performance. That's something you cannot really find anywhere, and it's really nice to have. As I already said, what's really important for you is to make sure that you already build your application on ARM, or you have at least have a CI/CD pipeline which can build the containers, so you can take them and your developers can use your application on ARM-based Macs, and you don't necessarily ask them to build that on their own. And yeah, so even Apple, what they are doing, they are putting a different like very specialized parts of the CPU to, for example, for neural training or for video translation and encoding to actually save some CPU cycles and memory. So why is AWS building their own CPUs? Like 10, 15 years ago, it didn't make any sense, but now it really does. And one of the things is that this is a Graviton we have right now is a third or fourth generation of custom silicon used by AWS. And they use this silicon in different places. One of them, and maybe a first implementation, was AWS Nitro. It was running inside every single server, which was like running Intel virtual machines, and was used as a hypervisor for that. And then, as Juraj already mentioned, we have different CPUs for inference and training, and those are also based on Graviton cores. And then we have AWS Graviton CPUs we are running on a third or fourth version right now. And so they are continuously improving this hardware, they're continuously adding new features and making the performance better. What's really interesting, what might be interesting for you, is that while in Intel, you have usually a virtual core you have in your EC2 instance is a thread running on a CPU, In an ARM-based instance, it's a physical core. So you have your own physical cores running your workload. Also, as I said, ARM instances are much cheaper to run for AWS, so you have a better price to performance ratio too. And what AWS did, and we saw quite a good difference there, was that they moved most of their managed instances to Graviton. So you can run Redis, RDS, Opensource, Kafka on ARMs, and the performance is much better. Like you can actually see the speed bump just keeping the same instance size and moving to ARM. You don't necessarily see any difference, and the speed is better. So, as I already said, we are in a 4th version of the Graviton processor right now, and this one is almost 40% faster than the previous version, and you can find 96 cores inside, which is really amazing. That's a really good CPU, and obviously you can use it to run very scalable workloads. Also, you can put a lot of VMs there. That's why AWS is doing that. It's easier to run and it doesn't cost that much money. Even Graviton 2, where we did most of our evaluation, was a little bit better in different workloads and benchmarks than already in that time running instances. So I prepared some benchmarks because we run them to evaluate the CPUs and to figure out if we want to use them in production or not. So I forgot which one is which one. Oh, amazing. Oh yeah, whatever. So we try, what we did, when we were actually trying to evaluate CPUs and ARM versus Intel, what we try to do is we try to run some different benchmarks to evaluate which CPU behaves in a certain way. And what we find out is that in multi-core performance, Intel was a little bit better, and in single core, ARM was better. But yeah. And when we were, you can find it here. Yeah, and so we were trying to figure out if that will if we would be able to see that in production. So what we did, we tried to run different couple of nodes with ARMs and put different pods there. But to be honest, we didn't saw the difference there. More or less, it was about the same, and that also came up with the different issues. This one is probably ARM, and this one is Intel again. But again, ARM is looking a little bit better here, but also in the real life, it was almost the same. So what we find out was when we try to run Graviton instances inside a Kubernetes cluster. That's really important. So when we try to do that, we find out that there were quite a lot of add-ons on Kubernetes which didn't have ARM 64 version yet. It was changing quite a lot, from day to day. You could find the basic add-ons running. That was really nice, but there also were some which we couldn't really run on Intel, on our ARM. So we had to find a way how to. So even if we would migrate all the workload on ARM, we still would have to keep some Intel instances there. So we also did quite a lot of updating of different charts, building different images, and pushing them to back to community. We played with that for about a month, and we updated different software, but at the end of the day, it was quite a lot of work. So what we really had to do, and we played with that for a while, was we tried to figure out how to build Intel and ARM containers together. Initially, we tried to do that within GitHub Actions. You can run a QEMU and you can build your image there, but it takes forever and it's really, really slow. So then we tried to figure out a different way, and we ended up with using a different ARM and Intel nodes for builds within our cluster. So we use instances to build our containers there, and that works very well. We use our own hosted GitHub Actions runners, and that's working well, and the speed is quite similar. One of the things we find out during the test run and during the evaluation was that Kubernetes autoscaling looks at any CPU, and you can have this problem with just Intels also. In the same way, it looks like this CPU has 2 cores. That means that you have 2,000 millicores available, and you can split that however you want. But it doesn't really look at the difference performance-wise. So you have different CPUs which have different performances in the cluster. Sometimes when you run 2 or 3 production pods on the same node, that node can handle that. For example, C7 or C6 pod node can handle that, but C5 or C4 will not be able to run that workload. And same thing was happening with ARM. We could run our production there, but we saw different hiccups and issues there, where if you try to run too many pods at the same time, it could cause some higher latency or issues in the production. So we were looking at a way how to tell autoscaler, okay, if you have ARM node, you cannot really put 3 or 4 pods there, even if the requests are the same. And that you cannot really do that right now. So you have to have different deployments for ARM and Intel. And yeah, it's quite complicated, and it doesn't really scale very well. Yeah, and this is what I'm trying to say. 1,000 millicores in C7G 2x large can handle different workload than C5 2x large or C7 2x large. And one of the best things is that if you want to run ARM, then you should probably run ARM altogether and not really try to mix it up. So this is how we created a GitHub action to actually build a ARM container, and you can see that we are using QEMU here to do so. This is just an example. We are not really doing that in production, but if you want, I can give you this code. So we also created our own software. We call it ARM U Ready to actually evaluate your cluster and figure out if you have some containers which are not really ARM64 compatible. So if you go here and fetch that, it's a Go binary, you can find it on GitHub. If you go there and run it inside your cluster or inside your pod, it can figure out how many containers do you use, what are the images there, and it will try to figure out if they are ARM64 compatible or not. The second thing is that and I already told that, is that you have to look at your software and maybe have a good observability in place, so you can actually you trust your setup, and you make sure that if anything changes, you have higher latency, you can detect that. Because even if you are moving between 2 well-known architectures, this is not something which is really different. There will be differences in the speed, amount of workload any CPU can handle, and it will be a little bit different. Also, there are still changes in Linux kernel, which are improving the performance of ARM64 implementation, so be aware of that. And there is very nice, AWS Graviton getting started repository, where you can find different CPU optimization flags, how to build your software if you have any C libraries inside, or how you can actually run it there on Graviton efficiently, and it's really nice. So yeah, benchmarks are really nice, like everyone loves to look at the different graphs and everything, but for us, we, at the end of the day, decided to not use ARM nodes in our cluster, and we are quite happy with that for now. So it was too much hassle to run two different architectures. We had to figure out the auto-scaling in different deployments. And we couldn't really figure that out, and it was quite complicated anyway. So we went with Intel, and for now we are even if ARM can give us better performance, we still understand that it's quite complicated on the operation side. So this is something we will probably look into in the future, maybe with Carpenter. Also, do some A/B testing for you, run a couple of nodes and see if they behave in production and how they behave. And if you do that, it can give you a good overview of the performance. And don't be afraid to use Graviton in managed services. That works very well. RDS, Redis, Opensource, Kafka, you can go anywhere with that. Yeah, and that's it.